Hi, my name is Jeremy Adams, and I'm going to be going over Chapter 10, Question 2 from the study book. These are the questions. The question reads, provide the major and minor products expected to be formed under each of the following sets of conditions. You can see the sets of conditions to the left. Question A. This molecule reacting with hydrogen gas, lead, barium sulfate, quinoline, and methanol, otherwise known as Lindlar's catalyst. Lindlar's catalyst, in its most simple explanation, is that the metal, which in this case is lead, is going to reach out and grab the carbons that are participating in the triple bond from the same side and apply hydrogens from the same side to each of the carbons, as you can see in the demonstration below. Question A. We have this molecule reacting with Lindlar's catalyst to produce two orientations of the same molecule. As you can see that both of these are produced by a partial reduction, but Lindlar's catalyst is always going to give cis, meaning that the hydrogens are going to be applied on the same side. And so the resulting molecule should have both of its groups that are not hydrogen pointed in the same direction, as you can see on the pictures on the left, unlike the pictures on the right. There is almost never going to be a transalkene produced from a Lindlar's catalyst. Question B. We have this molecule reacting with sodium and ammonia. I just want to go over the sodium-ammonia reaction mechanism because I feel like it's important to know for these reactions. So we're going to start out with a carbon triple bonded to a carbon, and each of those carbons is single bonded to an R group. And we have a sodium radical coming over and donating an electron to the carbon, which kicks off a single pi bond, which is 2 electrons, to the neighboring other carbon. This creates what's called a radical anion. In the second step, we can see that the radical anion, or the anion portion of the radical anion, reaches out for a hydrogen off of the ammonia molecule. Once it takes this, the left side of the now double bond has a R group and a hydrogen connected to it. And that leaves us with one carbon radical single bonded to another R group on the other side. In the next step, you can see that the radical carbon reaches out to the radical sodium molecule and takes one electron, creating a carbon anion, which in the next step, that particular carbon anion reaches out and grabs a hydrogen, like in the second step, and creates a transalkene molecule. Orientation, as we can see here. The partial reduction produces the transalkene or a cisalkene. The major product in this reaction would be the transalkene. In this reaction, we are reacting this molecule with hydrogen bromide. Hydrogen bromide will produce two orientations of the vinyl bromide, which means a carbon double bonded to a carbon and one of the carbons has a bromide on it. The left image or the left molecule is much more stable than the right molecule because of where the bromine is, and is not on an end carbon like seen in the right picture. And for this reaction, we are reacting this molecule with sodium amide. Sodium amide is basically a bond creating molecule. And basically what happens is, as you can see from the leftmost picture to the middle picture, the sodium amide is basically stealing a hydrogen from the molecule and creating a double bond, in which it eventually creates a triple bond, leaving one less hydrogen than expected, which gives the negative charge to the end of the molecule and leaves a sodium positively charged outside of the molecule. Thank you for watching, and I hope you have a great day.